Good afternoon. I am Shelly Singla, lecturer from GPC Pune Majra. Today my topic is fiber optics, light propagation and applications in communication. So first of all we will understand what is fiber optics. So we will define optical fiber. An optical fiber is defined as it is an extremely thin and long strand of very fine quality glass or quartz which works on the principle of total internal reflection so an optical fiber is made up of either of glass or quartz or it can be made up of plastic also and it works on the principle of total internal reflection. Now these fibers are used to make to transmit light to make medical equipments like endoscopes and it is used in telecommunication. So there are various applications of these optical fibers. So first of all we will know its construction. So we will construction of optical fiber. So as we have earlier said that it has two layers. It is made up of basically two layers. The first layer is known as core and the second one is called cladding. The core is very thin tube or pipe its diameter is of the order of 10 raised to power minus 6 meter and made up of very thin very fine quality of glass or quartz and the other one is cladding. It is the outermost layer layer of optical fiber its refractive index is less as compared to core. Index is less than that of core. So, this is the basic construction of optical fiber. We can draw a diagram. So, an optical fiber is basically a very fine tube or strand or a pipe. It has two layers. The inner layer is called, this one is called core, and the outer layer is cladding. The core has refractive index mu1 and its refractive index of the cladding is mu2. Now, when a light ray travels from outer medium to the optical fiber, so mu1 is greater than mu2. So, at the interface of core and cladding, it gets total internal reflection. This is the interface of core and cladding. So, once it has entered the optical fiber, it suffers multiple reflections and it comes out as such without the loss of energy. So, this is incident light ray, this is emergent light ray. So, with the help of this optical fiber, we can send our data or images in the form of light, and it can be obtained at the other end as such without the loss of any energy and with very much speed. So, this is the basic concept of optical fiber, and there are a number of thousands of optical fibers are packed together to form a light pipe. So, whenever there are thousands of optical fibers packed together, they form a light pipe, and another layer called buffer coating protects the light pipe from irregularities, distortions, and roughness of adjacent surfaces. So, this is the basic construction. Now, we will understand what are the materials used for the construction of optical fibers. So, what should be the properties? So, basically there are two types of materials used, either plastic or glass or quartz. These are the materials used for making a optical fiber. We can take their combination. First is glass core. The core is made up of glass and cladding is also made up of glass. The second is glass core and plastic cladding. The third one is plastic core and plastic cladding. So, there are three combinations of core and cladding, but the first one is preferred over the third one because the output is more of a glass core and glass cladding as compared to the plastic core and plastic cladding. So, this is most efficient optical fiber. So, what are the properties of optical fiber, of materials used for making an optical fiber? The first property should be that the material should have high elasticity so that they can be drawn into very thin and long drawn into thin and long fibers. This is the first and most important property. The second property should be that it should be transparent so that it can guide the light properly at a particular wavelength to guide the light properly. And the third property should be that materials of different refractive indexes should be used for core and cladding. So, these are the four basic and most important properties for the materials which are used for constructing a optical fiber. Now, we come to the process of total internal reflection. So, to understand the concept of working of optical fiber, we need to understand the concept of total internal reflection. So, it is defined as the process of reflection of light when a light ray traveling from when it is traveling from denser to rarer medium and it comes back to the denser medium at the interface. So, this is the definition of total internal reflection. So, there are two conditions required for total internal reflection to take place for TIR. The first is the light should travel from denser to rarer medium and the second is the angle of incidence should be greater than critical angle for the pair of media. So, these are the two important conditions. Now, we will draw a diagram. Suppose we have two different mediums. Suppose this is the first one and this is the rarer medium and this is the denser medium. Suppose a light ray travels from denser to rarer medium. If it is incident perpendicular to the surface, and then it will travel straight line without suffering any reflection or refraction. And suppose if it is incident at an angle I, then it will suffer refraction, and as it is moving from denser to rarer medium, it will move towards the normal. This is normal. This angle is angle R, angle of refraction. Now, third case is, let it is incident at an angle I which is equal to C. C is called critical angle, and it depends upon the pair of media, denser and rarer media, which media are we using. So, at that angle, the angle of refraction will be equal to 90 degree, which means the refracted ray will travel on the surface of the denser medium. Now, the fourth is, if this light ray is incident at an angle greater than critical angle, then it will come back in the denser medium back. So, this process is called total internal reflection. So, we need that the angle of incidence should be greater than critical angle for the total internal reflection, and light ray should move from denser to rarer medium. So, these are basic conditions required for the total internal reflection. Now, according to Snell's law, the law is used for refraction. Sine of I upon sine of r is equal to refractive index of the rarer medium with respect to denser medium, or we can write it as refractive index of rarer medium upon refractive index of denser medium. Let us suppose that this rarer medium is air, so its refractive index will be 1, and for this denser medium suppose we have refractive index mu, so we can write 1 upon mu. So I is equal to C. If I is equal to C, R is equal to 90 degree, we can say sin C upon sin 90 degree is equal to 1 upon mu. So sin C is equal to 1 upon mu. Also we know that the mu is directly proportional to 1 upon lambda square. So we can say from 1 and 2 that sin C is directly proportional to lambda square, which means that the critical angle depends upon the wavelength of the light, and it also depends upon the refractive index of the medium. So more is the wavelength of the light used, more will be the critical angle, and if refractive index is more, the critical angle will be less. So this is the formula used for the total internal reflection. Now next we come to the working of the optical fiber. So firstly we will draw the diagram. Suppose this is our optical fiber. It has two layers. This is core and the outer one is cladding. The refractive index of core is mu1 and cladding has a refractive index mu2, and the condition is that mu1 should be greater than mu2 for the total internal reflection. Let us suppose a light ray is moving at from air to the optical fiber, then at the interface of cladding and air it will suffer some refraction. So it will move towards the normal and then it will come to the interface of core and cladding. So we know that mu1 is greater than mu2, so it will remain inside the core. The angle of incidence here is greater than critical angle. So there will be multiple total internal reflections inside the optical fiber, and the light will come as such without suffering any loss. So this is the working of the total this optical fiber. Now next is the types of fibers. Here we have three types of optical fibers. The first one is single or mono mode fiber. Mono means single, so it transmits only one mode of propagation of the light, and the second is multi-mode step index fiber. In this optical fiber there are different modes of propagation of the light. The third is graded index fiber. So these are three types of optical fibers. So first one is single mode fiber. Let us draw the diagram. In this case we have core and cladding. The diameter of the core is very less. It is of the order of 8 to 12 micrometer, and the cladding has diameter of 125 micrometer. So in this fiber there is only one mode of propagation of light. That's why the diameter of core is very less, so it is used only for single mode of propagation. And the second is the mu1 and mu2 are the refractive indexes used. The refractive index of this core is constant throughout from the center to the boundary. It remains mu1, and mu2 is also constant for the cladding. Now the second one is multi-mode fiber. This is step index fiber. So in this fiber we have the diameter of core is very large. This is of the order of 50 to 200 micrometer. It can range from 50 to 200 micrometer, and the diameter of the cladding is from 125 to 400 micrometer. So there are different modes of propagation of light. mu1 changes abruptly to mu2. So this is for the step index fiber, that mu1 changes abruptly from to mu2. The third one is graded index fiber. So the difference between grading index fiber and step index fiber is that the refractive index of core changes slowly from center to boundary of the core. Boundary of core, and then to the cladding. So there is a slowly change of refractive index from the core, from the center to the boundary as well as to the cladding. So these are the three types of optical fibers. Now we will come to the advantages of optical fibers. As compared to copper wires. The copper wires can also be used for transmission of data, but there are certain advantages of optical fibers. The first is that it is flexible.